Physical geography is the study of Earth's natural features, processes, and landscapes, focusing on the dynamic interactions between the atmosphere, hydrosphere, lithosphere, and biosphere. It encompasses a broad range of topics, including climate patterns, landforms, ecosystems, and the forces that shape the planet over time. Unlike human geography, which examines the relationship between people and their environments, physical geography seeks to understand the fundamental workings of Earth's systems, providing insights into the natural world and its impact on societies. One of the core elements of physical geography is climatology, the study of weather and climate patterns across different regions. Climate is shaped by various factors, including latitude, ocean currents, atmospheric pressure systems, and topography, all of which contribute to regional variations in temperature, precipitation, and seasonal cycles. The influence of climate extends far beyond mere weather conditions. It dictates agricultural productivity, water availability, and even human settlement patterns. Understanding climate systems is crucial for predicting long-term changes, particularly in the context of global warming, which has led to more frequent extreme weather events, rising sea levels, and shifting ecosystems. Landforms and geological processes are another major focus of physical geography. Earth's surface is constantly being shaped by internal and external forces, including tectonic activity, erosion, and deposition. Plate tectonics plays a crucial role in the formation of mountains, valleys, and volcanic regions. The movement of these massive plates beneath Earth's crust leads to earthquakes, volcanic eruptions, and the gradual reshaping of continents over millions of years. Erosion, driven by wind, water, and ice, gradually wears down mountains, carves out river valleys, and reshapes coastlines. The interplay between these forces determines the physical landscape of our planet, influencing where people build cities, cultivate land, and extract resources. Hydrology, the study of Earth's water systems, is essential to understanding how water circulates through different environments. Rivers, lakes, glaciers, and oceans play critical roles in sustaining life, regulating climate, and shaping landscapes. Water is constantly moving through the hydrological cycle, which involves processes such as evaporation, condensation, precipitation, and runoff. This cycle ensures the distribution of freshwater across the globe, impacting ecosystems and human activities alike. However, the availability of freshwater is not evenly distributed, leading to regional disparities and conflicts over water resources. Rising concerns about water scarcity and pollution highlight the importance of studying hydrology to develop sustainable water management strategies. Biogeography explores the distribution of plants and animals across different regions and the environmental factors that influence their survival. Ecosystems vary widely, from dense rainforests and sprawling grasslands to arid deserts and frozen tundras, each adapted to specific climatic and geographical conditions. The interactions between organisms and their environments create complex food webs and ecological balances that sustain biodiversity. However, human activities such as deforestation, urbanization, and climate change have disrupted natural ecosystems, leading to habitat loss and species extinction. Studying biogeography helps scientists understand how species adapt to environmental changes and informs conservation efforts aimed at preserving biodiversity. The cryosphere, encompassing all frozen water on Earth, is a key component of physical geography. Glaciers, ice caps, and permafrost store vast amounts of freshwater and play a significant role in regulating global temperatures. Ice sheets in Antarctica and Greenland are particularly influential, as they reflect solar radiation and help moderate climate conditions. However, rising global temperatures have accelerated ice melt, contributing to rising sea levels and altering ocean currents. Understanding the cryosphere is crucial for assessing the impacts of climate change and predicting future environmental shifts. Coastal geography examines the dynamic interactions between land and sea, focusing on processes such as erosion, sediment transport, and tidal movements. Coastlines are constantly changing due to the effects of waves, currents, and human development. Natural barriers like coral reefs and mangroves help protect coastal regions from storm surges and erosion, but human activities such as construction and pollution threaten these fragile ecosystems. Rising sea levels pose additional challenges, increasing the vulnerability of coastal cities and island nations. Studying coastal geography provides insights into sustainable management strategies that balance development with environmental preservation. Natural disasters are an integral part of physical geography, demonstrating the power of Earth's natural forces. Earthquakes, tsunamis, hurricanes, and volcanic eruptions can cause widespread destruction, affecting populations and economies. While these events are unpredictable, physical geographers analyze historical patterns and warning signs to improve disaster preparedness and mitigation efforts. Advances in technology have allowed scientists to monitor seismic activity, track storm formations, and develop early warning systems, reducing the impact of natural disasters and saving lives. In conclusion, physical geography offers a comprehensive understanding of Earth's natural systems, examining the interactions between climate, landforms, water, and ecosystems. It provides valuable insights into environmental challenges, such as climate change, resource management, and biodiversity conservation. By studying physical geography, scientists and policymakers can develop strategies to protect natural landscapes, mitigate natural disasters, and promote sustainable development. As human activities continue to shape the planet, the study of physical geography remains crucial in understanding the forces that define our world and ensuring a balanced coexistence between nature and society.